We're now going to go ahead and turn to the next page, 459, and we're going to go through example A. A lot of the work that they have right here, they go through kind of pretty quickly, so I'm going to go ahead and do my work off to the side and explain it a little bit more so it makes sense. Let's go ahead and start drawing each of the lines connecting our center of our circle to each of the vertices of our polygon. Now, as we're going through this, we can also figure out how many sides it is. We can see that this is going to be an octagon. Now, they gave us that each of the side lengths here is going to be 8 inches long. They also decided to draw the apothem for us right here. And we know that's going to be represented by A. Now, what is it asking us to find? It's asking us to find the area of the regular octagon with those side lengths. So let's approach this like we did before. So previously, we wanted to figure out, okay, what each of those angles was worth inside here. They're all going to be worth the same, but we got to figure out what that's going to be. Okay, well, we know that since there are 8 sides, there's going to be 8 central angles. So in order to find one of the central angles, we have to take 360 and divide it by 8. That gives us 45 degrees. So each of these angles is 45 degrees. Now it's up to you if you want to label all of them. I'm not going to label the one with the apothem because it's a little bit hard of space, but we can see all those are 45 degrees. Okay, great. Now let's center in on this triangle that contains the apothem. So I'm going to draw the triangle over here, kind of in the margin to help us out. I'm going to suggest you do that as well. And we know that A represents the height of our triangle. We know that we have 4, which is half of 8. That represents, right, kind of that base area. And we also know inside, remember, that angle is half of 45 degrees because we have half of that. We have 2 of those that make up 45 degrees. So that's going to be 45 degrees divided by 2. So that's going to be 22.5 degrees. Now, our ultimate goal is to figure out what the area is going to be. Now, for the area formula we kind of came up with, we realized that it was 1/2 times whatever the apothem is. So we need to figure out what the apothem is times the perimeter. So let's start figuring out what A is. Well, this is a tough one because it's not a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle. So you know what we have to go back to? We probably have to go back to some trig ideas. Yeah, there we go. We're going to be going back to SOHCAHTOA. Hey. Okay, so we know this angle. And we have the side that's opposite from it and the side that's adjacent to it. We don't have the hypotenuse. So which one of the options is it going to be? Ding, 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 you got it. It's going to be TOA. That's what we're looking at. All right, so let's set this up. That means we're going to look at tangent and set it equal to the opposite over the hypotenuse. So we're going to have the tangent of our angle of 22.5 degrees, and we're going to set it equal to the opposite side, which is 4, over the hypotenuse, which is A. Now, if you remember how to solve for A, go ahead. Sometimes we had that little trick. If X is high, then we can multiply, or if X is low, then we flip them, bro. You can follow that pattern. I'm going to show you how to work it out just in case you don't remember that pattern. So to start to figure out what A is, maybe we want to try to get A by itself and make sure it's not in the denominator. So what I'm going to do is I'm going to go ahead and multiply both sides by A, so those cancel out. Multiply this side by A. So now I have A times tangent 22.5. Now remember the tangent of 22.5, that stays together, remember? So that's equal to 4. Okay, how do I get A by itself? Well, I divide by tangent 22.5. I divide by tangent 22.5. So my apothem A is going to be equal to 4 divided by tangent of 22.5. Awesome. Okay, now here's the hard part. When we put this in our calculator, right? Okay, I'm going to show you exactly how to do that. So I'm going to come down here. Now to put this in our calculator, I'm going to think of you having a normal graphing calculator. So we probably want to type in 4. Oops, sorry, that's highlighter. I want something a little darker. We're going to type in 4. You're going to do the divided by sign. Go ahead and put a parentheses. Find the tangent button, and the tangent button is going to type in something like that. Click 22.5. And then what you're going to do is you're going to put two parentheses, one parentheses to close the 22.5, and then one parentheses, the other one on the end represents closing the tangent. That whole entire thing is going to be, dividing 4 by that whole entire thing. So when we do that correctly, we should end up getting 9.657. So remember, that's going to represent what the apothem is. Okay, cool. Let's keep that in mind. Let's keep going. So now, okay, we have this idea. We got it right here, looking good. We got our apothem. Now we have to figure out what our perimeter is, because we have to take 1/2 times the apothem times the perimeter to get that area. So our perimeter, right, is just knowing, okay, it's going to be 8 times however many sides. So our perimeter is going to be 8 times 8, which is 64. Nice. All right, now let's finish this off. We're going to go ahead and look at the area formula. So the area is 1/2 A times P. Remember where that A is the apothem, so that's 9.657. And we're going to times that by the perimeter of 64. And you know how to put that in your calculator. So when we do that, we get 309.0 inches squared, because remember that represents our area of our whole entire octagon. Let's go ahead and let's now look at our next practice problem. What we're going to do is we're going to skip B and C. So go ahead and skip those. What I am going to do is I'm going to do part A, but I'm going to show my work down here because that's not really enough space for us, and I want to make sure we can draw the picture to understand this. So our problem is asking us to find the area of a regular pentagon with side length of 12 meters. So I'm going to go ahead and I am going to draw my pentagon. That means it's a 5-sided figure. Remember, we added that on our word wall along with a 6, 7, and 8-sided figure. Okay, and then we're going to have our center, and then we're going to go ahead and draw each of the segments from our center to our vertices. Perfect, looking great. Okay, well, we know eventually we're going to need to have, right, our apothem. We're going to have to find that, but we're also going to have to find, what that measure is of that angle as well. So let's start off with what we know. We know that there are 5 sides. So in order to find the central angle, we have to take 360 and divide it by 5. And that's going to be 72 degrees. So you could go ahead and label all of them or just one of them. I'm just going to label one of them so that way we know that. Okay. Now, let's go ahead and take our triangle that has the apothem, and we're going to draw it on a little bit of a bigger scale so that way we can kind of see it. Now, this angle right here is going to be 72 divided by 2, so that's going to be 36 degrees, just so you can kind of have a heads up on that. They also give us that the side length is 12, so that means this whole side is 12, so half of it for that part of the triangle is going to be 6. Now, unfortunately, this is not a 30, 60, 90 triangle, so guess what? We're going to have to use some SOHCAHTOA. We're going to have to use some trig to figure out what we're going to have, and remember, we're going to be looking for side A for the apothem, okay? So we have this angle, we have the opposite, we have the adjacent. Okay, ironically, we're doing TOA, tangent, again, so that means we're setting up tangent of 36 degrees. Remember, tangent or sine or cosine, whatever you use, always goes with the angle. And then we're setting it up as the opposite over hypotenuse, which is 6 over A. So similarly to what we did in the other problem, right? We can figure out how to solve for A. I'm going to cut a little bit of work. I'm going to use that shortcut. If x is high, multiply. Well, x is not high. X is low. So I'm going to go ahead and I'm going to flip these two terms. So I'm going to have A equals 6 divided by tangent of 36. I'm going to put that in my calculator, and from the previous problem above, you know how to put it in your calculator. When you get that, you get 8.258. Now remember, that represents A, our apothem. We need our apothem along with the perimeter to figure out what the area of this pentagon is. So now we're going to go ahead and try to find the perimeter. Well, remember, perimeter is going to be however many sides times their length. So each of these is 12 long, and we have 5 of them, so we multiply them together. Voila, we get 60. Remember, that's our perimeter. So now let's finish up with our area. Area is going to be 1/2 A, which is the apothem, times P, our perimeter. So we have 1/2 times 8.258 times 60. All right, put that in our calculator. We get 247.7 meters squared as our area. Nice. All right, good deal.